So MVP and I, we've been joking around past couple episodes about how we're eventually going to have like little astromech droids or little R2D2 droids be like our little toolbox companion slash robotic mechanic to help us out on our inspections and maintenance.
Yeah, it's joking slash super hopeful that actually happens.
Yeah, super. I mean, how cool would that be?
Awesome.
How cool would that be, right? Actually having like, okay, this may be ways away into the future, but actually having like a mechanic droid to just help you out on your day-to-day maintenance, right? Like it doesn't have to exactly take over for you, but like it has all like the specs and it can project it as a hologram, or it has like the engineering drawing and it can tell you exactly where things are being. It's like a certified NDI, so you don't have to like go find really expensive equipment.
Yeah, it can do on the spot soap samples and hydro sample analysis.
Yeah. And I'm not saying like we're replacing people's jobs, but like say like something where it's like a lot of travel work, unless like it's one of those in-depth, like you need a person watching this, but like say like on-site soap samples, just feed it into the droid in this little coffee cup or espresso cup of a thing, you know, maybe
or like,
wait.
Yeah. Sorry, I didn't mean to cut you off. Go ahead.
No, go ahead.
I was going to say where it's like, hey, you got to do like an engine burn in. It's like a 5-hour burn in, and some aircraft, you can run from a laptop, right? So you could that could be the laptop. They just plug themselves into the jet and sit there for 5 hours on a burn, and they got all the safety protocols built in, monitoring the stats or whatever. They'll shut it down before anything catastrophic happens, and you can bug out for the night. So think about that. Like you could head out and be like, all right, at the end of the shift, I'm going to start the 5-hour burn. That way, by the time I come in tomorrow, it's all done, and we can just pick up with the soap sample have already been taken or whatever. By that point, we can move on.
Right. And I mean, this is going to be a little bit of autonomy on the robot side of the house. But again, like with the way things are going now, I mean, shit, look, we got robots that can walk and hop obstacles, that know how to pick themselves up when you push them over and stuff like that. Or even now, like we got cars now that are slowly but surely being pre-programmed to drive themselves to and from their destination. I mean,
and do so repeatedly without incident.
Yeah. Or like there's experiments nowadays with certain type of airplanes that can land on them by themselves, So I'd say probably like in the next 20 or so years, it's not that too far-fetched of a dream where you can get a mechanic droid or mechanic robot that knows how to discern a 5-hour engine burnout and a soap sample.
Yeah, it's got its own. It can disseminate those out, print you the lab reports. You get it on the spot, and you go back. I mean, God, it would minimize your downtimes exponentially, right? And then imagine if you're sitting out there, oh man, working through this. I need a part, and the little robot orders it for you, right? It pulls up the IVP, searches through, gets the part number, and then orders the parts for you. And then think about as you're doing the job, that because almost all aviation that I've dealt with recently have all moved to electronic logbooks, computer-based systems, and that droid could be simultaneously in the background filling out paperwork and everything for you, and then all you would have to do is give the official, like your fingerprint on your droid. Just walk up and boop, and it signs it right by your fingerprint.
Right. Yeah.
God, that would save so much time. But now this is the part where I'm going to get greedy with it. What if it had its own like little coffee maker and little cooler in the bottom, so I can keep some waters and energy drinks in there too?
Oh yeah.
Hey, whatever your robot's name is, can you give me a cup of coffee, 2 half and half, 2 sugar, please? Beep,
Right.
Boop, beep, and it starts doing its thing.
Right. And it pops out like a vending machine, like, or it has this little arm that gives you a coffee cup.
Yeah, it's like R2D2's little probe that comes out, and it's just got is holding your cup. It's like a crappier Wally. You know what I mean?
Yeah. Or what's that one scene from Rick and Morty? Like, what is my purpose? Like, you give me coffee. Oh God.
Oh my God. Yeah. What is my purpose?
Right. So that's in the semi-distant future. I mean, I would say probably no more than 20 years, but that's the semi-distant future. In today's world, in the present, we are technically trialing, or we're experimenting on actual robots to help us with inspections. Now, these aren't like the astromech droids that we were just describing, but imagine that, like,
Well, it's all going to start somewhere, right?
Yes. And aircraft maintenance, whether you guys would, if people out there would like to admit it or not, is almost 20% of the total cost it takes to run an aviation gig. So 20%, if you guys know some of that rules, 20% causes 80% of your problems. So
Yeah.
having something as advanced as a robot, or air quotes semi-advanced as a robot, really helps in the maintenance of it all. What we were talking about earlier, yeah, sure, that's a little bit of ways away. But here in the present, using robots, even though they're not technically robots or autonomous robots, is in the works now, and it's a pretty big deal. Like, I don't know when they started doing this, but they started using like little quadcopters to help with overhead inspections on top of an aircraft. And
yeah, I think it's been a couple of years now. I know like they would use them on like some of the jumbo jets, right? Like a 787 or a 747. I know the 747s for a long time were having a problem with the back skin buckling a little bit.
Mm-hmm.
Like, you know how it kind of bubbles and then slopes down towards the rest of the backbone of the aircraft? Right in that slope area, the back skin was found to be buckling some. So I know they were coming out from like LAX, the maintenance crews, to like the boneyard that's just out north here in Mojave, and they were going and taking old back skin off of 747s out there in the boneyard to take them down and replace it with the buckled stuff on a still active jet. So I know they were using it for that to sort of spot for things like that, or, you know, looking for potential bird strikes, stuff that might be hard to see from a maintainer's view on the ground. Because look, if you're looking at the top of the vertical from how tall I am standing on the ground, I'm not going to be able to see that high. I can promise you.
Right. So like something like a quadcopter, right? Granted, it doesn't sound as advanced, but picture that, you know, just the labor and the level of inspection that you have to go through just to look at these areas. And all you got to do is just like have like, I don't know, a $200 freaking toy that flies, go up there with a camera, like a little GoPro camera, and just take pictures or scan that immediate area of what you're trying to look at. And you get so much intricate detail in just like, I don't know, 2 minutes versus like getting all the support equipment out there. You got to get like this very high ladder or platform that can actually reach up that high. You got to have a safety harness, a safety belt, all those things, right, to prevent falls. You climb up that aircraft, and even then, you know, you're trying to look at this area, depending on where it is and what time of day it is. You know, it can be very challenging to visually inspect these areas. And then if it's one of those like areas that seem kind of questionable, like it looks like damage, but it doesn't really. So now you got to have like this special test, right? Like say NDI or a dye penetrant or some kind of laser measuring tool to see if this area is bad. And just picture like the amount of manpower you just wasted for that specific task versus just like having like a $200 drone flying it up there, having to do silly circles for 5 to 10 minutes, take pictures along the way, and you have a way better result, or at least a better initial result than wasting 2 to 3 hours to get support equipment, get up there, and then visually inspect only to arrive at the same question, which is we need further testing. You know?
Well, and remember, right, they're not just, you know, for all the listeners there, they're not just taking the store-bought, your run-of-the-mill store-bought drone that you can get for $200 and using, strapping your own, you know, use your phone to basically fly it around, or you strap your phone to it and using that to fly around. It's like one of those ones where it has like the VR goggles and the people race with them and all that kind of stuff.
Yep.
But they also have modified cameras that are strapped to these things as well. So like it a little more in depth than just your run of the mill surface, you know, camera. Like this one's got a little bit more clarity and resolution and can kind of pinpoint some more defects that might be hard to see with the naked eye, you know.
Very true. That's a very good point. I didn't mention that part, and I kind of glossed over that. And some of these cameras, like what MVP was saying, is they can very sensitive, right? Like they can check like hot spots or they can check high spots, or like what you was talking about earlier with those buckling panels or those buckling areas. If a camera can snapshot that, or a drone can snapshot that flying however many feet above the area it's flying at, and you're seeing this real time through a set of HUD goggles or whatever controls you're using for this thing, that is a game changer to maintenance. Because again, going back to like how much manpower you're wasting just to set up the same type of a task, and spending hours of manpower cost just to arrive at the same answer, which is we need this, or we need to do we need a more in-depth inspection. This kind of stuff like saves. It's expensive now because, you know, it's technology, it's robots, it's still very experimental, but the long-term gain from this is like exponential almost, depending on what the application is. And this one, you're kind of incurring the upfront costs now for some of these that are trialing or doing trials on these. But in the long run, you know, like once you actually get these up and running and it's fully tested, you can save thousands, maybe millions just in your maintenance costs, because now you're able to pinpoint exact hotspots or exact trouble areas within minutes versus hours. I mean, I'm sure there's like a prep time for these drones or these robots, and there's preventative maintenance on these things as well. But then if you think about it,
minuscule compared to the large jet that's carrying people around, and way less in-depth inspections. I mean, hell, as long as the battery's charged, is really all you got to do.
Right. And then plus with these robots coming in, and of course, these robots are going to need mechanics of their own. So imagine that being a robot mechanic, if that makes any sense to you.
Well, or you as the maintainer now, right? You're assigned your own quadcopter and your own little R2D2, and you're also responsible for the general upkeep and whatever's required to keep those wheels turning, right? You might even have to learn a little bit of coding, but hey, that might be the future of A&P schools too, right? You know, A&P schools tend to be a little on the primitive side, and I get it. It's funding. It's hard to get for a school latest and greatest electronic stuff, but as time marches on, like Six has said, and technology improves, there's no choice. There won't be a choice where you'll come out of that school. Yeah, you'll get your A&P, your airframe and power plant, but you also might have a minor in software coding, just specifically for those little droids.
Right. And even today in the present, a lot of A&P training is starting to lean toward avionics. I mean, you kind of have to know a little bit about avionics just to compete in today's world. Like with the 787s, for instance, a lot of their troubleshooting is just printing off a receipt from the aircraft's diagnostics. You know what I mean? Like that kind of troubleshooting didn't exist 20, 30 some years ago, but here we are today, and the aircraft basically talks to you, more or less talks to you. I mean,
it tells you what's wrong.
You know, and this one of more prominent aircraft mechanics on social media like puts up like these videos of like just showing just how intricate some of these little tiny sensors are within an aircraft, and it's just meters upon meters of just aircraft cables or avionics cables, and they're all plugged into all over the skin. It's almost like this thing's nerves because there's just so many wires. And
tells you heat, temperature. There's like oh my god, what are those things called? Like row cell. They do your X, Y, Z axes, and they're like they basically electrical current. So as the skin of the aircraft moves and twists or whatever else, it'll shoot signals out and show that, oh, we have a twisting in excess of twisting in this area, or in excess of, you know, skin stretching. You know, the skin stretching due to the speed and the heat generated by the friction just from flight. Or like the buckling on the backbone, right? That those little sensors would tell you that you got buckling issues happening.
Yeah. And so imagine like having a computer that plugs in to talk with the other computer and then spout out like mechanic friendly terms, you know, like stress this or NDT that or soap sample this, and it's verbatim, it's translatable to like a write up, right? Or how whatever the regulations say. So it's almost like dummy proof of how to figure out or diagnose what's going on with the aircraft, right? I mean, do we see a time when robots would straight up take over mechanics? No, because with the amount of intricate work and the amount of detail that goes into it, I mean, as smart as a robot can get, I don't think it's going to be so smart where it starts making human decisions, unless.
Well, I think in a production style setting, right, building from scratch or whatever else, it repeats the same process over and over and over. It bangs the same rivets on the same panel or the same part of the fuselage day in and day out, week after week after week, maybe. But like in an AOG setting or flight line maintenance setting, I don't think it'll be able to make those hip fire decisions, right? It would only know, if you came up to a component and you're like, okay, what's this thing? Do we have parts in hand? No. Well, it's got a flight tomorrow. Is it on the MEL list? And the robot would be able to tell you, yep, it's a part of the MEL list, but unfortunately, the other two parts of this system that make it redundant are already MEL'd. So now this is the third one and we're out. And you have to repair them all now. So then it's like, okay, cool, I got to repair them. It puts the parts on order, generates the write-ups, and you're on your way. But
yeah,
I think you're right, Six. I don't think it'll work in an AOG setting because, like you said, the mechanic for the mechanic robot, somebody's going to have to take care of that thing. And there'll be some IT work involved and whatever else. But again, if you're a road dog, like most of us in this industry are, your IT nerds aren't going to be out there with you too much.
Yep.
You're going to have to fix it on your own. Yeah, you call back and you'll talk to them and they'll kind of help. It's like dealing with an FSR now or dealing with an OEM specialist right now. If you need help troubleshooting, but ultimately it's still going to be on you to fix it and whatever else. Or let's say you're out on the road and the robot takes a shit and you're like, well, the processor fried on it. Hell's bells. I don't know what to do now. Somebody's still got to fix that jet, and that's where it's still going to be you. You're still going to need those skills to press forward. That's the contingency plan, right? Mm-hmm. So moving forward, you have robotics and everything else, and that's the primary, and it's saving time and money. But what's your contingency when the electronics inevitably fail?
Yep.
Back to good old humans and human error.
Yep.
And that's what you have to default to.
Yep. And I think that's probably looking for as far as like the robot repair or the robot cert. I think that's going to be another training opportunity, right? Like, you're a certified A&P and you're certified to work with robots, right? So like the double value or however you guys want to market that salary.
Well, or it'll be like, right, you can just get your airframe and not have the power plant, or you could just have the power plant and not your airframe. But I also think it'll be, just one of those additional. It'll just be like another check on your license, right? You got your airframe and power plant card and the sub certificate of robotics operation and repair.
Right. Like AP&R. AP&R.
Yeah. I mean, yeah, it could exactly be it. That's just one of those like, hey, you're out there and you can still work on a plane. You don't need a robot to work on the plane, but you might find it helpful, or your company might be going, hey, it's like I mentioned with those 5-hour burn-ins, we're going to spend some upfront costs here because we're going to be able to save time and effort in the long run, where we can have these robots out here and performing engine runs and whatever else and diagnostics, and we don't need humans to work overnight anymore.
Right. So this, speaking of that, as far as emerging robots, this was actually an article in 2019 where they're talking about, it looks almost like a moon rover or an RC car of a robot, but it sticks to the hull of the aircraft and it just kind of crawls up and around it, kind of like a spider, or a wheeled spider, I guess you want to call it that. But it goes up, it wheels around the hull and it scans the hull as it's rolling. So it kind of does one like those buckling inspections, right? Or those airframe rivet inspections.
Mhm.
And this was just in 2019. This was actually promoted by the European Commission for that robot initiative. So we're already seeing robots that can climb around the aircraft, not just fly around it. So I venture to say probably
this thing stick to the hull though.
That I'm not too sure. It doesn't say a whole lot as to how it's doing it, but
Obviously, it wouldn't be magnetism.
yeah, I don't think so. Unless they figure out a way to magnetize aluminum or titanium, but
Yeah,
but yeah, it's wild. Like it's just rolling around on the hull. Like how is it doing that? That's still pretty crazy. But imagine that, like it's going around and it has like this flush measuring tool scanner as it's rolling along, and it can check like all the different high low spots or stress points
and
on
like
the hull.
3D map it almost, and then auto put it into like your like I know some electronic maintenance tracking documentation systems, they have an overview of the aircraft, and you actually can map skin defects on the airframe.
Mhm.
Right, you do a write up and it'll auto generate lat long, using water lines and all that kind of stuff to give you accurate measurements. So that's something that this could probably do too.
Ain't that nuts though? Like I remember there were times, or at least in our younger years, right? The only thing calibrated you have as far as like that kind of automation was like a torque wrench. Or like you have some individuals that have like really fine calibrated fingertips, like they can tell which spots are high or which spots are stressing.
Yeah.
And you wonder like how the hell does this guy come up with? And some people they can get it down to like within plus or minus 2 of the actual measurement. Like how the hell do you guys do that? And it just basically boils down to experience, right? Like some absorb faster than others, or some are just that talented where they can really feel the nitty gritty of certain things. But that those are like outliers because there's not that many mechanics out there or technicians out there that are that talented that can do that kind of stuff. I guess what I'm trying to mean is like the reproducibility of it all is not that great.
Well, I was thinking like even with composites, right? Tap testing,
right?
I've been on an all composite airframe, and it had 170, 180 foot wingspan or something like that. It was a big bird, but there was a group of like 10 people, and all you hear is the all day tapping around looking for defects in the skin. Whereas if you had a couple of those robots running around the hull, that thing could be NDIing your composite structures and finding weakness in the core or the resin or cracks, finding those fine cracks in there. Dye penetrant testing stuff. All that to save hours upon hours.
Yep.
Especially if it's something smart enough to be able to document it all itself too, or at least run a report that then you could input. But I think the ultimate goal would be to have it generate its own write-ups for the logbook.
Right. And then say something like with the tap test, or like say just guys feeling it with their fingers. Those are very subjective too, right? Because it may be high or low to you based on whatever airframe or model that you trained on, but it's not the same here, right? Versus like say like with robots, they get the latest and greatest updated info depending on how they get it. Like say they plug into the internet every so many days, weeks, months, and then they get the latest bulletins as far as what's safe and what's not.
Yeah, auto updated. But even, like you were saying, one person, looks at it and specs it and measures it out or feels it out and says, this is wrong and it needs replaced. Well, okay, but what are the exact measurements? This robot might even be able to, and it's been proven already that these robots can get more exact measurements than a human can at some points. So you could, it's not right or it doesn't feel right, but it's within limits.
Right.
People's like, well, it's not 100%. You're like, right, but it's within limits. And that's the whole reason limits exist, right? That's if you go tell your boss like, oh, this needs changed out, but it's within limits, they're going to go, I'm not downing the jet to fix something that's within tolerance.
Right. Absolutely.
Otherwise, these things would never fly. But that's the whole reason tolerances and limits exist.
Right. And And we're not trying to say like, oh, like mechanics are obsolete and it's now all about these new robots, right? That's not at all what we're saying, and I don't think that's ever going to happen. What I think with these robots or these new emerging technologies is doing is it's standardizing the reproducibility of it all, right? Like,
Yeah.
instead of like saying like, oh, my fingertip says this is 2 to 3 thousandths low or 2 to 3 thousandths high. Now we have a robot with an actual scanner with objective standards and measurements.
It's essentially sort of taking out the human error aspect.
Right.
And don't get me wrong, there's still going to be errors with whoever programs these things or whatever else. But again, as we've all seen already, it's more accurate with the way these electronics and softwares are being developed, and it's like you said, the reproducibility is just, you get a set standard and that's what you work to.
Right.
Rather than I feel this way or I think this way, or yeah, it's within limits, but it could be better. Sure, could be better. And if we had time, maybe we could look into it. But time is money in aviation, and it's within limits, so we're going to keep going.
Right. And then with now having like a set standard of what you're actually measuring, or at least a trend of standards you're measuring, that bleeds into the quality assurance of it all. So like you can talk about what's our highest drivers for problems, right? And you actually have like a legitimate answer versus like
trend analysis. Yep.
Right. Versus like having like a subjective measuring, right? Based on what these many persons feel about the issue, right? That's especially apparent with certain measuring devices, right? Like they're using it wrong, or they don't know how to read it, or if they look at it a certain way, it reads one way, and if they look at it a separate way, it reads another, right? There's all kinds of errors when it comes to measuring, and for most precision standards, they factor that in. Like, this is how it's going to read if you do it this way, which is wrong, or which is not exactly correct. And depending on the error of which it is, it could be plus or minus 2,000s, or it can be plus or minus 5%, which can be a big deal depending on the tolerance. But again, like having something as accurate or standardized as, say, a robot, now the only error is in the decision of whether to work on it or not.
Well, check this out, right? We were talking about trend analysis. So let's say you and I go out there and we're looking at, you have a weekly inspection, right? A lot of these jets have weekly, monthly, whatever maintenance checklist you go over, and you say, okay, I noticed this the last time and I wrote it up, but it was within tolerance. Let me just check it again. And you're like, well, what was that the last time? And that little robot can pull up and like, well, last time it was at, the tolerance is 1 to 2, and we were at 1.5. Okay, we're within tolerance. We measured this time and it's 1.7. All right. Let's continue to monitor. And the next time it comes down, we're at 1.9. Oh, this thing's clearly creeping itself outside of tolerance. It's obviously something going wrong, and you could dig into it a little bit deeper. But again, you have that trend at that point. You can show when you write that up and say, hey, we got to stop. We got to look into this a little bit more. They can say, well, why? It's within tolerance. Yeah, but I've been checking this over the past 3 months, and it's slowly working itself outside of its safe operating limits.
Yeah.
Okay.
Yeah, like it's trending faster than it should, right? Because a lot of times, like, oh, well, that's wear and tear over time. Like, sure, but even wear and tear has a limit, right? Like, right. It's not supposed to wear out in 3 months when it was designed to wear out in 30 years, or something like that. Stuff like that. Exactly.
So you can find trends that way, and it just helps you make better decisions, I think, as a maintainer as well. You can go, some people just go, oh, well, that's still 1.9, still within limits. Yeah, it's been creeping out. Or they might not even look at that. Oh, it's within limits. Yeah, but it was more within limits, and then it's now walking itself out of tolerance. Why is it walking itself out of tolerance?
Right.
And
I imagine, like, say the near future is now, and we get these astromech style droids. I'd imagine they'll only have like basic understanding, because they'll probably just roll out of the assembly line like a new aircraft mechanic or new certified aircraft mechanic would. Like they have the general knowledge, but they don't know the full extent of how an operation works. So you imagine like you have to teach this thing, right? So you got to teach a robot as if you would a human student. Like,
almost. And what if it's, it's Skynet, right? What if it's capable of learning? So as it's on the job with you and it performs jobs and jobs, and it learns more of what it's supposed to be doing or what it should be looking for, what it should be tracking. It learns how you operate as an individual, right?
Yep.
And knows that you like to start, over here first on your inspections every time because of X, Y, and Z reasons. So it's already prepared and it's got that data points pulled up. I don't know.
Right.
Again, that's some Skynet shit.
Right. Imagine, man, like you got to teach this robot its job. And then in the process of learning its job, it learns stress. It learns how to be depressed.
It just starts dismantling itself.
Right.
You're like, hey, man, we're staying out in the line like we were talking the other day. Oh, my God, how are we going to get these 5 jets fixed by tomorrow morning? And all of a sudden you just see your T-8000 Terminator just reach around and push the button on the back of its head and power down. Like, no, robot. No, you're supposed to help me. Every time you turn it on, it just shuts itself off again. No, creator. I am not with this today.
Like, I can't handle this shit, man. I'm not made for this.
It just hits its self-destruct button. Self-destructing in 3, 2.
You just see
it melts. It's just smoke coming out of its cranium. Oh my God!
Imagine that, right? Like work life is so stressful that machines can't even handle it.
Yeah, you're looking for your robot and you find it in the smoke pit with a cigarette hanging out of its mouth.
It's like Bender, you know what I mean? Like
it's Bender. It's like from Futurama. It starts drinking and it can only function if it has alcohol in it.
Yeah, it starts learning how to cuss. But it's not like actual cussing. It's like some R2D2 beeps and whistles. I'm like, the hell's this freaking robot problem? And it's like just on a giant rant about how it wasn't created to handle stress.
So here's beep boop beep boop beep. Yeah, I know it's messed up, little bot, but this is the issue. Beep boop beep. Whoa! Don't let him hear you say that. Beep boop beep boop beep. I bet his mother does that too.
Imagine that. That'd be so hilarious. I'm actually looking forward to that. That'd be hilarious.
I can't wait, to be honest with you. I kind of hope that happens. I want my own little Bender robot. Bite my shiny metal ass. Hey, you get back here.
You get back here right now. Don't you walk away from me.
Walk away from me. And then everybody else in the line's looking at you like, we're just having a rough day. We'll get through it. We'll get through it. Like it's a real person,
Yeah, like you and your best friend just had a fight.
It's like you and Master Chief and Cortana, right? They're having legit conversations. You start losing grip on what reality really is.
And you're both all sitting there in the pipe, just like, well, here we are, like have like that depressive pause, like you just don't know which way to go, so you just kind of sit still until you figure it out.
Till you figure it out together.
Oh, heck, that's great. I'm can't wait for that.
That's awesome.
Man, technology. It's coming, man. I have a deep feeling, especially nowadays. We already have drones that can attach themselves to the hull of an aircraft and just scan it like a NDI would. And like, only a matter of time, man. I see it happening.
Yeah, like there's a video actually attached with this article, and it shows it creeping across the engine cowling of a 737.
Mm-hmm.
But I still don't understand how it's adhering itself to because it looks like it's just got these like your normal RC car when it calls itself off-road and it's got those little spiky knobs on the tire. It just looks like it has 4 of those in a big capacitor sitting in the middle of it with a cable that's attached to it that just drives around. But I still can't figure out how, because it's riding right on the side of the cowling going east to west, We're actually fore and aft.
Mm-hmm.
Yeah, it's just going fore and aft. It's interesting.
Yeah, it's like gecko feet, you know what I mean? Like we don't know how it's doing it, but it's just doing it.
Yeah, I'm trying to read through this article here and see if it explains motorized wheels machine use intense suction climb the outside of the aircraft.
But I don't see
composites.
But like I don't see suction. Like when I hear suction, I think like octopus feet. Like
yeah.
But I don't see that on this thing. Maybe it's just that small. That's why it's able to just crawl around like it is. Either way, that's pretty cool, man.
Can you imagine having that? Oh yeah, well your mom uses intense suction. You're sitting there talking shit to your own little personal mech robot.
Right, it starts roasting.
No, your mom uses intense suction. Oh. It just throws down its tools, storms off.
Or it just like it ejects all the coffee in its coffee maker part and like no.
It just pours it all over the ramp. Now, listen here, I know we've had our difficulties, but that was uncalled for. Like you just, again, having like real life conversations and arguments like you would with anybody else.
I think that'd be hilarious, man. Like it sounds stressful, but imagine like having that deep level of an argument with a robot.
Like the AI is so good. But it's got to be where it doesn't talk back like in whatever language you speak. It's got to be in beeps and whistles that you can understand.
Right.
Because that just, to me, makes it so much funnier.
I know, totally. So, like, what do you guys think, you, the listeners? Like, do you feel like robots are the way of the future? Do you think we're going too fast? We're going too slow? What kind of applications you feel robots can have? And what sort of stuff is what you'd like to see in the future? Let us know, please, in all of our social medias or on our website. Final thoughts for any of this, MVP?
No, I think this is the way.
This is the way.
This is the way. Yeah, I think it's going to be really good. Like we've had conversations with other people who are in the industry, and there's always going to be a need for people to maintain these flights. Not going to stop anytime soon, right? Ever since we started flying, humans haven't stopped, and we've always been pushing the limits. And you've seen it all across the news. Everybody's trying to get to space, and that's the next thing. We're still going to need people to work on these things, even when they're traveling the cosmos. Mm-hmm. And these robotics will just make life. It'll just minimize time and effort. And I think even, we've talked a lot about mental health on this show, but I think it'll even help with mental health because, you got guys who've worked, night crews for decades and not seeing the sun really takes a toll, right? Mm-hmm. But if everybody can work 9 to 5 type thing, so to speak, and the robots are where they're with you, but they can continue on with the trivial tasks that don't need, the human brain as the final say so. They can run those trivial tasks throughout the night and just pick up where you came in the next day. I think it'll make our lives easier just having the most latest and greatest tech on hand at all time, no matter what job you go out there for. You don't have to comb through the IPBs, the fault isolation trees. You don't have to sit there and go, what task was this? You can just say, hey, find me right inboard aileron actuator install. Boom, it pulls it up. You know what I mean?
Yeah.
It's right there for you. I think the biggest thing where it'll save us all a lot of time and headache is the generation and completion of write-ups.
Yes.
If it's working that simultaneously as you're going over and analyzing things, and you get done, you can say, okay, here's everything we got done today, right?
Mm-hmm.
And it's got the write-ups already generated, whatever else. And then think about this. It's also it could be running a pass down, or you could be talking to it like, hey, take this note for the pass down. And then as the next guy has come on shift, it dumps it to a database, and all the robots pick it up when they come online. And then as you're sitting there making your first cup of coffee for the day, or your robot is, if you're lucky enough, you can say, hey, read me, what jet am I assigned to? Oh, you're assigned to tail number XYZ. Cool. Give me the pass down on XYZ. And it reads you off that report of what was done for that day. And it shows you all the write-ups and everything else, man. That's where it's at.
Yep. And it kind of gives you like an alert, like a real-time alert whenever something gets generated, like alert, a new bulletin has been issued or some shit like that, right?
Or think about this, like, right? It'll also be tracking the tools you pull out, right? Maybe your box has an interface where that that robot plugs into it and it does a quick scan of the whole box and it's saying, oh, this box is missing something already. Oh, shoot. And it'll auto generate out a missing tool report. And so everybody can stop. If let's say it's right at the beginning of the day, boom, everybody stop. Don't sign anything out. We got this thing missing. What's up?
Right.
And I think it'll help minimize those kind of issues as well.
Most definitely. And all this stuff, man, like of all the little menial stuff or the high alert things can be instantly accessed and generated, that thing that saves tons of time and just adds to our performance, say our effective performance in our job, which is keeping planes flying and keeping them safe. I feel that's our opinion anyway. What do you guys think? Let us know in the comments as well.
Yeah, for sure. I'd be curious. And if anybody out there is actually working on this new development, let us know kind of where it's at and what you guys are seeing as the next steps.
And on that note, thanks again, everybody, for listening, and we'll catch you guys next time.
Beep, boop, beep.
Beep, boop, beep, boop. We'd like to take this time to thank our patrons for supporting our show and allowing us to continue to make episodes, maintain our gear, and create merch for all of our listeners, with special thanks to Erica Lamont, Chris Hawkins, Ryan Freshour, Dan Schubert, Jenny Dignan, and the ladies of the Dick Talk and Mimosas podcast. Thank you all so much for your support and patronage. Visit our shop at cancelformaintenance.com and grab some swag to show off both your support for us and your prowess as an aircraft technician. If you have ideas for the show or you'd like to be a guest on the show, visit our contact us section and send us a line. We will do what we can to get your ideas or yourself on the show. You can also follow us on social media, such as on Facebook at Cancel for Maintenance, Instagram at Canx, that's CANX for Maintenance Podcast, or on Twitter at CXMX Podcast. Check out some of our affiliates like Rockwell Time, where they make both rugged and classy watches to fit your lifestyle. Use the code CX4MX and save 10% off your purchase. Support us on Patreon. Our patrons get exclusive perks such as access to our Discord, discounts and early access to merch, special patron-only episodes, and so much more. Thank you again so much for listening, and we'll see you next time.